Welcome to the wasmCloud machine learning subgroup for Thursday, March 31st, 2022. Christoph, I think that you put some kind of notes together for next steps in the wasmCloud machine learning channel. Let me get those kind of pulled up here, and or if you want to share your screen, maybe we could kind of talk through what we think some of our next steps might be with the framework. So by the way, incredible job on getting the everything released. I know that it looks like people were putting in a lot of work on getting some more realist examples for TensorFlow and the Onyx stuff working. And that is just awesome work across the board. But maybe I think our sort of goal for the day is to put our heads together and kind of figure out what should the demonstration look like over the next few weeks here or months that we want to build together. Is that right? Is that where you think we are?
Yes, absolutely. Sorry, I was muted. Yeah, absolutely.
Great. So in the code that you put out, you've got 4 different models working. 2 are around object detection, and I don't remember, one is your toy, and then there was another one that you did. But you've kind of laid out a sort of set of next steps here around maybe doing a low latency, a streaming kind of a demo here. Getting it up and working for the TPU on the Coral Dev board, which I think is an interesting idea. Maybe the Intel Neural Compute Stick, and then possibly doing a face detection demo. I think what we should probably try to do is come up with an idea that gives us a fast follow, like a quick milestone that we can, what's a quick win, would be maybe something that we can take a real picture and get a real result out of. And then we look at making sure that the demo then has a roadmap that we can build to. So we start with maybe a local demo of face detection that gives you the coordinates from a picture. And then we move to maybe a little bit more structure, and then we make it distributed, and then we do a demo of building Nest as a service. Maybe some thoughts around the table for what people think about that.
Good idea to make it in little iterations. I mean, sure, we can start with pictures or images. Yeah, that makes it easy. So to look for a good model first.
Yeah.
So one of the things I like about the idea of image recognition is there's a lot of models to choose from. One thing I don't know about face detection is, because I haven't worked with it specifically, is what's the accuracy of an untrained model? In other words, if you take an off-the-shelf model and you wanted to use it in your home Nest doorbell, don't you need to train it on the faces of your family to get good accuracy, or does the off-the-shelf model work with faces it hasn't been trained on? That's something I just don't know.
Yeah, it works. Yeah. Before I experimented with wasmCloud, I took some model from the internet and I put it I wrapped it in a Python script, and it detected my face. I didn't train it.
What about Intel, Minkyu, Johnny? What are your thoughts on the demo and what it should look like?
Yeah, I think the first step sounds reasonable. Start with image, and then we move from there. And I would suggest maybe take a look at things like a media pipe. They have like a kind of a environment for you to chain together, data processing, post-processing all together with the image classification. So that might be useful to move those sort of scriptable chain together in the cloud. Just
Okay.
idea. It's definitely not the first step, I think, for the demo, but potentially, that's sort of thing that could be done, for usability.
Okay. So what would the vision look like here, bringing media pipe in in here? Would this be wasmCloud is driving a media pipe client on an edge device and then sending it to the cloud, or what does that look like?
Yeah. So one possible, scenario could be like you have multiple service providers, and then you have some sort of like a scripting environment that basically chain them together, with a like a easy to use user interface, either like some GUI or some like a scripting environment that you can chain them together. I think that's how like those media pipeline software that they are doing their things. So it could be something like that.
Okay. So thoughts? Christoph, Steve?
Yeah, I'm not
Yeah.
familiar with what's available in the wasmCloud already. So maybe some of the capability it's already there.
The notion of pipeline doesn't exist yet, but you mean this as a rapid prototyping tool, right? That might be a good idea. I mean, to validate that the processing itself is correct and to validate that very quickly, correct?
Yeah, it's a quick prototyping environment. Yeah, data preparation, pre-processing. Those are like a very tedious steps, and different users have different requirements. And if you have to change your programming, it's very tedious process.
Okay.
So that's like a media type of software will, address.
Okay. So if we look at where we are now with the demo here, trying to pull up your repository. If we look at where the demo sits now, we're running models, but we don't have the sort of interpretation piece on these models here. Steve or Christoph, would you be able to suggest next steps for what we would look at next here with these?
I mean, to look out for a already trained model and which does face detection, I think is a good idea, as you said, Liam, at the very beginning, and to try it out with images. So not with a stream, not with a bunch, but with single images. And that can also be tested very quickly in the unit test. You can unit test the provider. I mean, I did that with, or we do that all the time with MobileNet and SqueezeNet. And that's cool. And once that works, so we can work on that low latency mechanism such that you have that you process them very quickly once in a sequence,
Okay. So what about when we think about managing the results, though, I feel like we have a little bit of work to do here to make the results, usable. What would we suggest for face detection? Well, I guess we need to understand what kind of tensors do the algorithms return? Do they return a set of coordinates in the image and say, here's the box around the face? Steve, do you know?
Yeah, go ahead, Steve.
Sorry, Andrew.
Steve?
Well, like I said, I hadn't used it yet, but I assume that it gives you a closeness match to the face you're displaying. You want to either gives you the closest match in the database or compares two faces and gives you a closeness match. And so if it was going to unlock your front door, then you'd have to decide it needs to be above some confidence threshold. Is it something like that?
Oh, okay. I did not have that same thought. I didn't know. My experience with object detection is bounding box based, like what Liam was talking about. And the question I had before was, okay, even if we get bounding boxes put around people's faces in an image, in our demo, I felt like our demo was, hey, let's capture the images in which someone's face appears. right? Because maybe it's a robber or something. And so we actually, the output that we want is not really the bounding box. We just want to know, is there a face in the image? So we sort of want a list of the objects detected in the image. And I think there might be a post-processing step there to take the tensor, the return tensor, and well, at least for image classification, what you'd get is this giant tensor, and it would have the probability of each keyword being in the image, right? And so maybe you'd have dog and plate and face, right? And face, if face is over 80%, then you want to send that one back or something like that. But that's for image classification. It's still sort of unclear to me if we want to do like this object detection bounding box stuff, or if we want to just do like image detection with like.
What do we think is easier?
I mean, I know the MobileNet stuff works pretty well.
So Andrew, you are talking about like a multiple inferencing steps, right? The first one is the object identification,
Right.
and then maybe like with the image with the face in it, then you do a second round of a machine learning, which is like look at the closeness of different faces and identify unique identity with.
But see, that's what Steve's saying, and I don't know how are we going to create a database of like our faces,
Well, I think we could load candidate matches in as part of a demo, right? Like I'll put my face on, you guys can like put me on GitHub. I don't care. So I like this because I want to make sure, Christoph, that we're meeting the needs for your goals, because I think that you have some demos that you want to give as well. And Minkyu and Andrew and Johnny, I want to make sure that we're meeting the needs of your goals, which I believe is that we do a lightweight detection on the edge. So maybe we'll do, in the dream where we're going is we'll do MobileNet on some edge device, whether it's a Google Coral TPU or an NVIDIA Jetson. And we'll use ImageNet there to detect the images with faces, and then we'll use wasmCloud to send the faces back to a different server in the cloud that's running on an Intel, whatever, and we'll use that one to do the face matching, right? So we'll sort of demonstrate lightweight algorithm on the edge and more powerful algorithm running in the cloud. Christoph, would that sort of general architecture work for you?
It sounds very good. Maybe I didn't understand it fully. My thoughts are still stick with what Andrew said. Maybe I can add to what Andrew said.
Okay, please.
But in general, it sounds very good. Andrew say, so when I was experimenting, I think it was not face detection, but people detection, but never mind. So, I mean, as I said, I took some model from the internet and I didn't train it, so it worked. The point is to make it interesting. Yes, right. I mean, there were bounding boxes coming out. You have to post-process them in terms of you have to scale them to the image size you want to display. And the point is you have to display, you want to display the image and to want to have an overlay with the bounding boxes. Just that people in the demo, they have to see that image with the bounding boxes overlays such that they see, yes, these are the boxes which match the people, right? Or the faces, whatever you do. And so exactly, I think, Liam, you said it, and we have to stream the image or send the image to somewhere and also the overlay, and that must match somehow at the end, right? So that's maybe, don't know yet how to do that.
We don't need to know how to do it just yet. I think the important thing we want to achieve today is that we're generally aligned on the mountaintop that we're going towards. And then it sounds like we have some pretty clear milestones that we could work in. So the first milestone might be to do this pre and post processing, so that we can have something to display to the user, like, hey, we're printing out to screen or putting in a database. What are the images or a JSON? What are the images in this picture? And then we're putting a bounding box around people's faces or people. Right, that would feel like maybe milestone one.
So I have so just I didn't want to speak up earlier just in case there was some conversation that I missed and was just ignorant of something. But from what was just described, do you think that the appreciation factor is there For example, how will users be able to see that, you know, certain computation happened on the edge and certain computation happened in the cloud, and really appreciate the performance gains that are coming from, you know, just kind of the infrastructure?
Well, I think the you know, all of the Corals and the Jetsons are all full functional computers that run Linux. So depending on how fancy, you know, we want to make this, it's either printing to screen or maybe you know, I don't know. I mean, maybe we need to think through that a little bit. There's probably a bunch of pre-canned demos that we can use, you know, or adapt the infrastructure from to give you the sort of presentation there for the edge, right? But I think we could have a way to show it on the edge or to report it back to something that's displayed on the edge. But I agree that there's probably half the work here is in the user experience of telling the story.
Yeah,
Mhm.
I agree with them.
Yeah.
Yeah.
And
So another comment that, like, you know, face detection, you know, it might be a too difficult task for the first step. You know, first step might be like just a motion detection. You know, if you detect, you know, whether it's an animal or it's a person, you know, something like that. So that would be you know, a more, you know, easier first step, I think.
Okay, so why don't we do for milestone 1 then? Why don't we set a goal of maybe testing a couple of these things on an edge device and seeing, you know, if the direction we're headed in is plausible. So we'll take MobileNet or one of the other image classification algorithms, and we'll go ahead and, you know, have it just echo out to screen, you know, what's in there, just print line or something. Does that feel like that would work, Steve? Christoph?
Yeah.
And that way we can agree, you know, we can maybe do, thank you, Christoph, thumbs up, appreciate that. We'll use that as the next milestone for this project. And then we can kind of dial in where we're going from there. So that feels like a pretty clear direction for me. Does anyone else have anything they want to bring up or chat about? Or is there other detail that we should align on here as far as what help we need and how we're going to do that? Steve, I feel like you guys have been you and Christoph have been working really well over Slack, I guess. So I don't know that we need to micromanage you guys or anything.
Great. Yeah, and Christoph's doing a lot of amazing work.
For sure.
So we're gonna do an image classification, and you know, we could come up with maybe a nice UI for getting the picture in, and then it'll say, is this an elephant or a screwdriver? And display the result on with the probability percentage on the screen.
Mm-hmm.
Okay. Yeah.
Can I make a quick comment?
Of course.
I am less interested in what type of inference we do. Yeah, everything everyone suggested is great, but from a benchmarking perspective, it would be great if we could gather data on the time it takes to do whatever inference we do down at the edge, right? Like have that time, have the time that's taken to do the inference up at the cloud, and then you know, what is the time, what is the latency in transmitting the thing up to the cloud thing, right? And how much data do we need to send up there? Like all those are key pieces that for telling that final story. Like I don't have yet a vision of how to present that, but we need to be able to start gathering that data either through a separate actor or I don't know, you know, you guys know better.
Let me show you an example of a similar demo here and see if this wouldn't resonate. And let me come up with like maybe a story, Andrew. Hold on, let me flip over to this. This is a demo that is going to be presented at KubeCon. So I'm just kind of leading the horse a little bit, but it's not really my story to tell because this was all written by someone else. But I got a decent slide here. Hold on. Share my screen. It's okay. It's anonymized. There was an organization that did a wasmCloud demo with us that was doing image background removal. And Andrew, let me see if I can play this out. So when they implemented a wasmCloud, one of the things they realized they could do was push the logic down to the browser. And what was powerful about that was it saved them the 400 milliseconds of transferring the image up and back. It was the same algorithm, so it was good. It was faster when it was pushed to the edge. It was only 40 milliseconds, and it was cheaper because they were no longer paying for the compute because it was happening on the edge. So if we're capturing the sort of metrics here around like image size, processing power on the edge, what's the sort of like curve and boundary to say it's worth doing this on the edge versus pushing the data back? That could be an interesting line of research to sort of study. Is that what you're going after, Andrew?
Yep. Yeah.
Okay.
Exactly. Right.
All right.
And maybe in our case, we have to also, we have to also do the complex inference down at the edge and say, oh, it's really slow, or it's impossible to do, or something like that. I don't know.
The face matching across like maybe 100 faces, is this a person we know? And it makes sense to do the face detection on the edge, but it doesn't make sense to do the face matching on the edge and the sort of large scale analytics that we need the big silicon for. That's the kind of theory. Okay.
And we're jumping the gun right now because we're assuming that the big silicon's like super needed, but I think if we start gathering that data, then we'll be able to tailor the story to, the data, right? Instead of the other
I think bullet B is what is the threshold when you do need to, if you're matching against 5 faces, it's fine.
Yeah.
But if you're trying to match against 50,000, it falls over. I'm sure that there's a curve.
Yep.
Yeah, I think just to add to that, I think maybe obviously telling a story is good, but what I saw is the flexibility and whatever your needs are. If you need to do more in the cloud, you can. Whatever you're optimizing for.
So, Leon, so that the case 2 is something you guys want to build or already built?
Say that again, Minkyu. I'm not sure that I understood what you're asking.
The slide that you showed, like there's a case study, case 2.
Oh, that's already built.
Oh, that's already built? Oh.
Yeah, that was built a long time ago. That was built like at least 6 or 9 months ago or something. Yeah, that's a cool demo. I think they're going to do that at KubeCon.
Oh.
So that's a powerful one.
Oh, that's a machine learning in the cloud and then migrate to the edge.
It's not machine learning. It's just a background removal from an image. But we could do the same sort of archetype with machine learning, right? With the machine learning model, and sort of decide: are we going to run this capability in the cloud? Are we going to run it on the edge, or is the business logic, the actor, going to run on the edge but use a capability in the cloud? It's hot swappable, so we actually have more than just A or B, because there's different pieces of the pipeline that you could choose to run in different places.
Okay,
right?
Got it.
Okay, and I think Steve introduced, we were having a conversation the other day, an idea here that can play into this story of, when to choose to process things on the edge would be, what did we come up with? Confidentiality, respecting machine learning algorithms, because there'd be sometimes, let's say that if I were doing cancer detection and I want to take a picture of my body to look for moles that, like I wouldn't necessarily want, I'm fine with my face going in GitHub. I don't know if I want my body pics going in GitHub, like, I'd just be embarrassed. Like for everybody else, not for me. So maybe like that would be a good case where you would want that done on the edge. Maybe we come up with a better story than my example. I'm glad we got this on video recording now. That's
on
just
tape.
Great.
Forever.
Yeah. Forever and ever. Yeah.
Yeah.
Forever.
So I've got a use case maybe to add, adds to what all of you said. So at my work, we've got data processing to do. It's kind of logs, but from cars then, and we do lots of processing. Time matters. And so one thing we could do to send everything up to AWS and the like, but probably, maybe we do not want to do it. So the same curve question, maybe. So that's what I want to see, if it doesn't make sense to process a lot of data where it is. Where it is where the
Yeah, I
data
mean,
sources.
Yeah, look, I think this paper, if we can pick the right demo, I think we can then introduce a lot of these variables around, what are the 5 compelling reasons that we may want to run data on, machine learning on the edge versus pulling it back, limited and deliberate autonomy, regulatory, like, GDPR or data privacy, data locality, privacy in general. The data's on the edge, maybe it's too much data. So I think we've got a good story here that I'm already thinking ahead to the real release, which is the shared white paper that we are all gonna get to set down on our boss's desk and be like, man, did I do a great job this quarter or what? Yeah, Intel, yes? All right, good. All right, okay, I think we're all headed in the same direction here. So next check-in, we'll want to just have some image. We're going to start with an image classification algorithm that's either echoing out to screen or something along those lines, and that's our next milestone. And then from there, we'll look at what the next milestone should be after that. Okay? Steve,
Yep.
we're all good? Christoph?
Yep.
Doing awesome, buddy. I really love all the stuff you're working on. It's amazing. Everyone else on the call? Jordan, we didn't hear from you today.
Yeah. Great job, everyone.
Okay, awesome.
I understood everything y'all talked about, I promise.
Come on, Jordan. Don't sell yourself short, man. Minkyu, Andrew, Johnny, it's great to see you guys as always. We'll chat soon,
Yeah.
okay?
Just one
likewise.
question.
Sure.
Leon, could you send me a link to your background remover demo or whatever? Give me a link. I will take a look at it.
Yeah,
It sounds really interesting.
I will message you on Slack or right offline, okay?
Mhm.
Okay, thank you. Have a great day.
Okay, goodbye.
Thanks. Bye.
But